Greetings, I'm Squared here. Today we're going to talk about writing piecewise functions. So a piecewise function is a function that has different rules for different intervals of its domain. Remember, domain, that's the x value. Whenever you hear domain in math, you got to think x. So you see the different intervals here. This is what a piecewise function looks like. So we have a function name, we have the different rules. There's 2 here, but you can have 3, 4, you can have a bunch of different rules. And then this is the domain that tells us which x values to plug into the rule. So for this one, it says x is less than 0. I would only plug numbers that are less than 0 in for this rule. And then x is greater than or equal to 0. Those are the numbers I would plug in for this rule. I would make my table of points and I would graph it, and it would look like this. You can see that if you're familiar with linear equations, these are both linear. This has a negative slope and a y-intercept of 3. This has a positive 2 slope and a y-intercept of 0. So you'll see that there's a 3 right there because we're on the y-axis with x equals 0. So you can see that the y-intercept has an open circle. That's because we couldn't use 0. We can go right up to 0 on this function, but we can't use 0 because it says it's less than 0. But for this one, we could. So open circles and closed circles depend on these little inequalities. Less than or greater than uses open. Less than or equal to, or greater than or equal to, uses a closed circle. So I just wanted to give you a general idea of what a piecewise function looks like, what the graph looks like, how I can plug x's. These x's are 0 or less than, so I'd plug them into that one. These ones are 0 or more, so I'd plug it into this rule because the domain interval tells me that. So we're going to just practice a little bit of evaluation, and then we're going to write some piecewise functions today, starting with absolute values. So let me where's my other paper? Hold on. So I was going to just look at this one for a second, just to do some evaluating with you. So you can see that this piecewise function has 3 parts. It goes from -9 to -2 for this one. My slope is 0, right? And my y-intercept would have been 1, 2, 3, -4. So this one actually looks like it's this line is y equals -4. But what I want to talk to you real quick about before we start writing is that you can evaluate this function without actually knowing the rules, just looking at the graph. So if I said, what is the value of f of 5? Let's say I said 5. So then I have to go to 5 on my domain, because remember, this is where x goes. So I go 1, 2, 3, 4, 5. And then I go up 2, and I see that the function is 2 when x equals 5. I could also say, what is the value of the function when x equals -6? So then I would go over 1, 2, 3, 4, 5, 6. I would go down, and I would say, oh, the value of the function is -4. So the value of the function in a piecewise function, you have to actually find which of the rules that they're talking about depending on your x. If I said, what is f of 0? F of 0 is 0 because up here there's an open circle. So I know it's not there. So I know at 0 it's right there. So I would say f of 0 is 0. Same thing for this. If I said, what is f of -9? It's this point right here. If I said, what is f of -2? It's not this one because it's an open circle, so I'd have to go way up here on the graph and find it there. Oh, I think that's a little off. That was supposed to be right there. Oops. Anyway, otherwise it's not a function. That's why that's an oops. Okay, let's look at some of these. Sorry about that. So one of the things you're going to have to do in your homework tonight is write absolute values as a piecewise function. So we draw the function name, we say equals, we have our little brace, and then this is where the rules go. So it's important to know where your axis of symmetry is. Your axis of symmetry is going to be whatever x value makes the absolute value inside there 0. These are really basic ones that we're going to start with. So our axis of symmetry is x equals 0. So that means when I do my little function, I'm going to have an x is less than 0 and an x is greater than or equal to 0. I'm going to have those 2 things. So remember, we've been doing a lot of observing of these functions, and this -4 tells me that it's a little steeper, that the slope on this side, it's upside down because of the negative, so that means the slope on this side is a +4, and the slope on this side is a negative 4, and because we don't have anything over here, it didn't change that. The vertex is also at 0, 0. So those are just things that we've been observing. Hopefully you've got those in your brain right now. So I know that I can write these two functions because I know that the first one, the one on this side, is going to be y. Oh, sorry, we don't need the y. There's the y. It's just going to be positive 4x, and that this one's going to be negative 4x because of that slope right there. So remember we talked about when this is negative, the left side is a positive slope and the right side is a negative slope. Here's our interval, here's our rule, here's our function name. Okay, with that in mind, we can see that this one's really similar. The axis of symmetry is going to be 0 because we just have an x in there. The vertex is going to be 0, 0. So that means my y-intercept is 0, 0. So this one's going to look like this. And so we're going to make our function and our rule. And we're going to say, so this one has a negative slope, right? Because it's going down. And this one has a positive slope because it's going up. Remember, this is telling us what the slope of the function is. So again, 0 is our interval cutoff where it stops going down and starts going up. So we're going to say negative 2.5x for any x that's less than 0. And we're going to say positive 2.5x for any x that's greater than 0. And that is our piecewise function for absolute values. And now let's just do a couple other ones that aren't, well, this one's again an absolute value, but it has a picture of the graph. And then we'll do one that's not. So the one thing you notice is that we're not at 0, 0 anymore for the vertex and the axis of symmetry. So we need to find that. So our axis of symmetry sits at x equals negative 2. All vertical lines are x equals lines. That means they don't have a y in them. So that's what our axis of symmetry is. So x equals negative 2. Our vertex is sitting at 0, negative 2. And those are kind of important pieces for our rule. So you can see the y-intercept for this side is 1. Well, what would the y-intercept be for this side? Because we aren't going to graph it, but we have to know what it is to make our rule. Oh, sorry. Let's find our slope first, and then it'll make more sense. So you'll see this dot and this dot. So if we go down 1, 2, 3, and then we go over 1, 2, 3, 4, 5, 6. So it's 3 over 6, a negative 3 over 6. So that's a negative 1/2. So then I can take this point and I can say, oh, my y-intercept for this side would be negative 1. And then I can take the slope and the y-intercept and I can first make my left side. So we always want to start with the leftmost interval. And we are going to write 1/2, negative 1/2, x minus 1, because that was our slope and our y-intercept for this side. And that started at x is less than negative 2. So right there is where we started noticing that this line stops, right? Starts here, well, kind of starts on forever, but anyway, this is where our interval stops going down, starts going up. The rule changes, I should say. So right here, our rule is going to be different. So now, what's the slope of this side? Well, if you've been remembering the absolute value thing, you'll know it just switches signs. It's going to be 1/2. But if you don't remember that, we're just going to check it real quick. Up 1 over 2, up 1 over 2, up 1 over 2. Yep, definitely 1/2. And then our y-intercept was 1. Put that 1/2 over there. And then that was for x is greater than or equal to negative 2. So this is our piecewise function for that absolute value. Okay, now we're going to try one where it's just two different linear functions. So ignore that little dot right there, okay? It's not supposed to be there. That's an oops here. Let me white it out. Okay, so here's two different functions. I have to find the slope and the y-intercept of each. This one's pretty obvious, right? So let's just look at this one for a minute because it's a little less difficult than that one because we already have our y-intercept. 1, 2, 3, 4, 5. So I know my y-intercept is 5. And then I'm going to find my slope. So down 2 over 3, down 2 over 3. Looks like the slope is down 2 over 3. So that's going to be this rule right here. So I'm going to say negative 2/3 x plus 5. And that's for x is what? It looks like x is greater than, this is our line where the interval shows us that the rule changes. It's the line where the rule changes. So we're going to be greater than a solid circle means or equal to -3. So then obviously this one's going to be x is less than -3. Okay, so now we've got to find this one. So let's find the slope first. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Looks like it's down 8, right 4. That would be a -2. Right? So our slope is -2. And then if our slope is -2, we can find it by just keeping on counting. 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. It looks like it's -9. So I'm going to say that's -2x minus 9 is our rule for the left side of -3. So you're used to writing equations from lines, but now you have to, on a piecewise function, you're actually writing equations for 2 or more lines. So you just have to get used to that and separating them, finding out where the interval starts and stops. All right, good luck with that. M squared signing out.